So today we're going to learn how to multiply polynomials algebraically without tiles. But before we do that, I would like to review with you multiplying monomials. Remember, that's one term. So these problems are monomials being multiplied together, and then multiplying a monomial by a binomial. Remember, that's one term times two terms. So to start off today, I want you to stop the video and try these 8 problems right here. All right, so take a moment to check to see if you did your problems correctly. A couple reminders: when you're multiplying monomials together, you're just basically multiplying the coefficients and adding the exponents to the variables that have the same variable. When you're multiplying one term by two terms, you're just distributing the monomial to the binomial. Again, remembering that you distribute first and then add like terms. So for example, number 3, if you accidentally did 5a plus 3a first, what you did there is you added before you multiplied. So you want to make sure you always distribute, then combine like terms. So if you look here, there are no like terms at all. So now let's look at multiplying a binomial by a binomial without tiles. One thing you may have started to notice is that every term has to get multiplied by every other term when you're multiplying two terms by two terms, okay? There's a method that we use called FOIL. And right down here, it tells us what FOIL stands for. It stands for first, outer, inner, last. I also put it over here. First, outside, inside, last. So basically what that means is you multiply the first two terms together. So if you look at this problem, x plus 2 times x plus 1. In this set of parentheses, the first term is x, and in this set of parentheses, the first term is x. So what you would do is you would multiply x times x. So I'm going to put an f right here, standing for first. So x times x is x squared, right? And then the next one would be our outside terms. So in this entire problem, my outside terms would be the x and the 1, because these are my outside terms. And this is drawing towards that. So that I'm going to put an O above. So x times 1 is x. So I'm going to write plus x. Then I'm going to do my inside terms. So these two numbers are my inside terms, right? If these are my outers, these are my inners, right? So I'm going to do 2 times x is 2x. So I'm going to put an I here. That's going to give me 2x. Then I'm going to do my last term. And so that would be the last number in each set of parentheses. So that would be the 2 and the 1. And you notice right here, I have another line. That is going to be my L. Then you multiply the last term. So 2 times 1 is 2. When you're done with that, if you've done it in the correct order, typically the middle two terms are like terms, and you can combine those like terms. So that's going to give me x squared plus 3x plus 2. So let's go ahead and try a few of these now. So looking at p plus 5 times p minus 4, basically I'm going to take the p and I'm going to multiply it by the other p. That's my first terms. Then I'm going to do p times negative 4. Those are my outers. Then I'm going to do the 5 has to get multiplied by the p, which is my inners. And then the 5 has to get multiplied by the negative 4. So basically, everything in the first set of parentheses has to get multiplied by everything in the second set of parentheses. And drawing these lines here might help you do it. So let's go back. P times p is going to give me p squared. Then I'm going to do p times negative 4 is negative 4p. Then I'm going to do 5 times p, which is 5p. And then I'm going to do 5 times negative 4 is negative 20. And then I'm going to combine my like terms. And my like terms are usually going to be in the middle, not always. And that's going to give me p squared plus 1p, which would just be p minus 20. And you're finished. So now let's take a look at number 2. So number 2, I'm going to take the 4x squared. It has to get multiplied by negative x. Well, 4x squared times negative x is negative 4x to the third. Then that 4x should get multiplied by the 7. 4x squared times 7 gives me 28x squared. Then I'm going to take the next term. The x in there has to get multiplied by negative x. So x times negative x is negative x squared. And then I'm going to do the x times the 7. X times 7 is 7x. So go ahead and now combine your like terms. 28x squared minus x squared is 27x squared. So this answer is going to be negative 4x to the third minus 27x squared plus 7x. So if you think you have it, you can go ahead and stop the video and try number 3 on your own, or just stick with me for a moment. So for number 3, I'm going to multiply 8a times 4a, which is going to give me 32a squared. Then I'm going to multiply 8a times negative b, which is going to give me negative 8ab. Then I'm going to do negative b times 4a is negative 4ab. Then I'm going to do negative b times negative b, which is positive b squared. Now you might have written that negative 4ab, you might have written that as negative 4ba, but typically we want to keep things in alphabetical order. That way we can see that the middle terms are like terms. Negative 8ab minus 4ab is going to give me negative 12ab. So this answer is going to be 32a squared minus 12ab plus b squared. All right, let's look at number 4. So for number 4, I'm going to start by doing g times g, which is g squared. Then I'm going to do g times negative a, which you could write as negative ga, or I'm thinking about my alphabet, I'm going to make that negative ag. Then I'm going to take the next term, my next set of parentheses, negative a times g is negative ag, and then negative a times negative a is positive a squared. Now the two middle terms, whether or not you wrote them ga or ag, they're like terms. Remember, those have coefficients of negative 1. So negative 1ag minus 1ag is negative 2ag. So my answer here is g squared minus 2ag plus a squared. All right? So now I want to talk about the order of your answer, because later we're going to do something called factoring, and putting things in the correct order is pretty important. So far, every one of these answers is in the correct order. You always want to, if you have the same variable, you always put the highest exponent first, down to the lowest exponent with your constant at the end. If you don't have a constant, it's just by the highest exponent, 3, 2, 1. Right? Here, you have multiple variables. Now, this is tricky. All of these have what we call a degree of 2, because there's 2 variables here, there is 2 variables here, and there is 2 variables here because it's b squared and a squared. Typically, what you would do here is you go in alphabetical order with the double variables right in the center. So the AB goes right in the center, sandwiched by the a squared and the b squared. So over here, this is not a big deal, but technically, if I want to put this in the correct order, I'm going to put the a squared first because a comes before g. So we could rewrite this as a squared minus 2ag plus g squared. So I'm going to say that is my final answer there. However, I will not mark that wrong. All right, so now let's try some on our own. What I want you to do is I want you to go through and I want you to use FOIL. So again, just a reminder, it might help to draw the lines. It's a good idea to do it in that order because later that's going to help us with factoring, knowing the correct order, okay? My challenge for you is to go through and do FOIL and then put your answers in the correct order. I want you to try to put your answers in the correct order, all right? So at this point, I want you to stop the video. I want you to do problems 5 through 11 on your own. If you get stuck, you can certainly come back into the video and check your answers on a few of them, all right? I will show you the answers in just a moment, so stop the video and then come back to me. Okay, here are the correct answers. You may want to pause the video so that you can see these answers right here and check your paper. A couple of notes. In question number 6, if you put 66 plus 5k minus k squared, that's not wrong. It's just that we want to put our variable with our highest exponent first. So this would be the correct order. All right. The other thing about number 8, when I went ahead and I did FOIL with number 8, I noticed that my like terms weren't in the middle. So that just means that the stuff up here was in a weird order. So what I did when I rewrote my problem is I knew, well, I needed the n squared first. So I put negative n squared first. I combined my like terms, put the n in the middle, and I put my constant at the end. If you have any of these terms if you have all three of those terms in your answer, it doesn't really matter what order they go in, all right? Now, number 11, of course, many of you probably put m squared plus 2mk plus k squared, which is perfect. It's just if we're going to be a stickler about it, which I'm not usually, the variable with k comes before m, so I rewrote it so it's k squared plus 2km plus m squared. Both of these are the same answer, okay? So it's fine if you have your answer like this. As long as your terms match my terms, we're good. All right, so we use the acronym FOIL to do a binomial times a binomial. But if I've got a binomial times a trinomial, that acronym doesn't work because we now have an extra term. So we don't do 2 terms times 2 terms. We end up doing 2 terms times 3 terms. So the same idea still applies. So basically this problem here, notice this x, this first term has to now get multiplied by all 3 of these, which is what I'm doing here. It needs to get multiplied by that. It needs to get multiplied by that 10x. It needs to get multiplied by that. And then this 3 needs to get multiplied by all 3 terms in the next set of parentheses. So basically, all terms in the first set of parentheses need to get multiplied by all terms in the next set of parentheses. So I did this problem here for you. You could just write down all of the terms just in a row and then combine your like terms. I'm going to show you another way to do it as well. But the other thing to think about is if I'm doing 2 terms times 3 terms, when I'm finished doing all of it, I should, in my first step, have written down 6 total terms. Because if you think about it, you're doing 2 terms times 3 terms, which is going to result in 6 total terms. Now, I like to do these problems because they tend to get really long. I like to do these problems by stacking them. So for example, if I were to do this problem, I would do my x times my 2x squared, and I would say that's 2x to the third. Then I would do my x times my 10x, and I would say that's 10x squared. Then I would do my x times my 1, and I would say that's x. Then I would do my next one. I'm going to go ahead and change colors because I can. Now the 3 is getting multiplied by all 3 of these terms. What I'm going to do now is I'm just going to stack my like terms, right? So now I'm going to do 3 times 2x squared, which is 6x squared. I'm going to put that underneath my 10x squared. Then I'm going to do the 3 times 10x, which is 30x, and I'm going to put that under my x. Then I'm going to do my 3 times 1. I'm just going to put that here. That way it's easy to keep track of what I'm doing, right? So this top line was the first term. This second line was my second term. Now, because I stacked them, all I have to do now is just combine my like terms. And so my answer would end up giving me 2x to the third plus adding these two together, I get 16x squared. Adding these two together, I get the 31x, and then I have the plus 1. So this is another way of looking at it. That really helps if you're doing 3 terms times 3 terms or 3 terms times 4 terms, right? Then if you do it a row at a time, it's easier to keep track of. So now stop the video. I want you to try 12 and 13 on your own and then come back and see. Don't forget to answer these questions here. Think about how many terms will be in your answer before you combine like terms. So I'm thinking like after you do all of this, just to check to make sure, how many total terms will you have before you start combining your like terms? All right, stop the video, give it a try. And here are your answers to the last 2. So what I did here is the 4x here on number 12 is being multiplied by everything here. Those are the 3 terms in red. And then the 3 gets multiplied by all 3 terms. Those are the 3 terms in blue. So notice there would be 6 total terms before I combine like terms because I have 3 terms and then 3 more terms. Down here, since I'm doing a trinomial times a trinomial, I'm going to have 3 terms times 3 terms times 3 terms, which will give me a total of 9 terms before I start combining my like terms. So the 5x squared is in red, The -4 is what I got in blue, and the green is what I got when I multiplied the two together. All right, that's your video for today. Let me know if you have questions.